Arctic sea ice extent decline. This refers to the long-term reduction in the total surface area of floating sea ice across the Arctic Ocean. Satellite measurements over several decades show a consistent downward trend, especially during the summer months when melting is most intense. As the ice edge retreats further north each year, large regions that were once permanently frozen are now seasonally open water. This shrinking surface directly reduces the physical space polar bears rely on for movement and hunting. Summer sea ice minimum. This is the point each year when Arctic sea ice reaches its lowest extent, typically in September after months of seasonal melting. The minimum level has been declining faster than winter recovery can restore it, creating progressively weaker ice cycles. With less stable summer ice, polar bears are forced to spend more time on land or swim longer distances between ice patches. This seasonal low point has become one of the clearest indicators of Arctic change. Sea ice thickness reduction. This describes the gradual thinning of Arctic ice due to warming temperatures and shorter freezing periods. Thinner ice is more fragile and breaks apart more easily under wind and ocean movement. Multi-year ice, which once survived several summers, is becoming less common and is being replaced by younger, thinner ice. This reduces the durability of the platform polar bears depend on for resting and hunting. Greenhouse gas emissions. These are gases such as carbon dioxide and methane released from human activities like burning fossil fuels and industrial production. Once released into the atmosphere, they trap heat and prevent it from escaping into space. This gradual warming effect increases global temperatures, with amplified consequences in polar regions. The accumulation of these gases is the primary driver behind long-term Arctic ice loss. Arctic amplification. This is a process where the Arctic warms faster than the rest of the planet due to feedback effects involving ice and sunlight. As bright ice melts, it exposes darker ocean water that absorbs more heat instead of reflecting it. This accelerates local warming and causes even more ice to melt in a repeating cycle. It makes the Arctic especially sensitive to even small global temperature increases. Rising ocean temperatures. This refers to the gradual increase in heat stored in ocean waters surrounding the Arctic region. Warmer water delays ice formation in winter and speeds up melting in spring and summer. Ocean currents transport this heat into areas that were previously stable and cold. As a result, the base layer supporting sea ice becomes less reliable over time. Polar bear hunting platforms. These are stable sections of sea ice that polar bears use as platforms to hunt seals, their primary food source. Bears rely on these frozen surfaces to wait near breathing holes or seal haul-out areas. As these platforms break apart or disappear earlier in the year, hunting opportunities become shorter and more unpredictable. This directly impacts their ability to store enough energy for survival. Ringed seal population dependence. Ringed seals are a key prey species for polar bears and depend on stable sea ice for breeding and resting. They build dens in snow-covered ice and use breathing holes in frozen surfaces. When sea ice becomes unstable or too thin, seal reproduction patterns are disrupted. This reduces food availability for polar bears across the entire food chain. Energy expenditure in swimming. This refers to the increased physical energy polar bears must use when swimming between distant ice flows. Swimming in cold Arctic waters requires significant energy and can lead to rapid fat loss. Longer distances between ice patches force bears into more frequent and more exhausting swims. Over time, this reduces their overall health and survival rates. Denning and reproduction changes. This describes shifts in where and how female polar bears build dens to give birth and raise cubs. Traditionally, stable sea ice and coastal snowbanks provided secure denning environments. As ice conditions become less predictable, suitable denning sites become harder to find and more exposed to disturbance. This can affect cub survival during early development stages. Ice breakup timing shift. This refers to the earlier seasonal breakup of sea ice in spring and summer compared to historical patterns. Earlier breakup shortens the hunting season available to polar bears before they are forced onto land. This disrupts their natural feeding cycle and reduces the time they have to build fat reserves. Over time, this shift changes long-established survival rhythms. Human industrial black carbon. This is a form of fine soot produced by incomplete combustion from engines, factories, and burning fuels. When black carbon particles settle on ice and snow, They darken the surface and increase heat absorption. This accelerates localized melting in sensitive Arctic regions. Even small amounts can contribute to faster ice degradation when combined with rising temperatures.